bit about myself. My name is Demeter. I'm a senior security researcher at the Global Research and Analysis team, which is Kaspersky's GREAT. Basically, GREAT is part of Kaspersky R&D, and we focus on targeted attacks. We focus on highly advanced attacks, researching and publishing, and of course, defending against APTs, attacks against governments, attacks against banks, and so on. So I mostly do, part of the team, I do threat intelligence by day, and I also have some hobbies like gaming and snowboarding by night. So today I would like to do a small introduction into what's been happening in the past 10 years in the threat intelligence industry, and then I will be talking about a framework which is extensively used in the industry, like the Yara framework. And basically it is used by a lot of people, and why maybe I can convince you of why you should be using Yara as well, or how Yara can help you, and what can you do with it. So thanks a lot to my manager, Mr. Costinaru. He initially prepared those slides, so I'm using some of his slides. So our great research before 2017, and this is because I didn't, if I add 2019, it will like completely overfill the page. Basically, you can see that these are the golden years of right now, like 2010, 2011, we barely started to scratch the surface of APT attacks. And this is interesting because basically right now it means that more and more attacks have been discovered in the past years. And in 2019, we had more APT groups than the entire slide that you can see it here. So that's pretty cool. And basically, what I want to tell you, I want to talk about some pretty interesting highlights, APT campaigns that happened in the past years, and are actually kind of interesting, and maybe it's worth mentioning them. And of course, it all starts with Stuxnet, because I think all of you heard about Stuxnet. It was a malware designed to infiltrate the uranium enrichment plant in Natanz in Iran. They managed, basically the attackers managed to successfully deploy the malware. It spread on out-of-band computers, so computers that were not connected to the internet, and infected the entire network. It basically destroyed the uranium centrifuges, and it rendered them failure. Their failure rates increased kind of like quite a lot. Stuxnet, a lot of people they consider Stuxnet to be the first cyber weapon to be deployed. But let's not forget, we're in 2011, and we have the DQ family. DQ family with its other siblings like Ghost, Flame, and Mini Flame, and then later, 2015, DQ 2.0. So DQ malware was again highly sophisticated and extremely powerful. It is based on the tilde platform because it used the tilde files like .tilde files, which were like this format. And what's interesting is that while DQ1 was used to target government institutions and any other entities, Flame was a destructor, like a destructive malware, which was aimed to wipe entire computers. And DQ 2.0, which actually infected our company, Kaspersky, is something that it's worth mentioning, and we found out later that it was related to DQ 1.0 because of code similarity. So this was powerful enough in order to infect our company, and was powerful enough to actually get past our protections and all the systems. So we discovered it, we researched it, and we managed to get rid of it after some time. I have to update Chrome. Yes, thank you. Red October was another campaign, but was like around 2012, 2013. It was targeting governmental institutions, and I think it's pretty interesting because it's one of the first campaigns that I personally saw affecting Eastern Europe countries, like Eastern Europe embassies, Eastern Europe governments. Mostly embassies in another country, and Red October is Russian-speaking APT. So basically, it was pretty interesting to see that some of the lure documents that they were using, and some interesting exploits they were using as well. So you can check out the blog post for this one. Dark Hotel is an APT which is pretty interesting. It was targeting Southeastern Asia entities targets, and basically it was meant to target VIP people who were going through hotels in the hotels. So basically, attackers were able to infect the hotel network, and then from the hotel network they knew which guests were coming in at that day, and then from that list they knew that those guests will actually use the hotel network. So they were waiting for those guests to connect, and then they were targeting those VIP persons, sending them malware by owning the hotel network. So this was pretty cool. We had a colleague who checked in at a luxury 5-star hotel, and he was never targeted. So he couldn't find any malware in being targeted with any malware in the hotel network. So that was kind of a bummer. My colleague, I think he was quite happy for staying at a 5-star hotel for like 1 week, but we found this APT eventually, and we wrote about it, and it was pretty interesting. Of course, we need to mention Equation Group, which we released and published a lot in 2015, 2016. It's one of the most powerful APT campaigns that we've seen. And basically, I think why I like it the most is the fact that they were able to inject and infect hard disk firmware. So basically, they were infecting the hard disk firmware, and whenever the sysadmin would reinstall Windows on those infected computers, the malware from the hard disk would reinfect those systems as well. So it was persistent after reinstall, after Windows reinstall. So this was pretty cool. Check out our blog post from Houston with Love. There's a crazy story with like some a CD being sent to one of the researchers. It contained pictures, but also it contained some malware in it. It's crazy. It's a crazy story. Same story. It's this crazier with satellite Turla from my point of view. It's a Russian-speaking APT, and of course you might have heard about Turla, also the other group Sophosy, Hades as well. But what's interesting with satellite Turla, because there's like a lot of Turla variants, and a lot of companies are researching about it. But what's interesting about satellite Turla is that they were actually using satellites as a means of communication. So they were using satellite communication links. So how does this work? Basically, their victims were located inside, let's say, Europe, yeah, or in Africa. But those victims were connecting to C2 servers, which were hosted on satellite IP ranges. So basically, the victim would connect, and it would receive commands from a satellite. But the problem is that a satellite covers an entire continent. So the question is, how do you know where is the physical location of the server sending those of the C2 server? Well, you don't know. You can just guess. It's somewhere in the area covered by the satellite. So read out the story. Is like pretty interesting. Unfortunately, I don't have time to go into it. And lastly, we go to Lazarus. Lazarus Group, which, sorry, what happened? I don't know what happened. Let's see. Basically, Lazarus Group, which was a Korean-speaking APT, and then they got also associated with by the NSA as well, and we also expose them. They basically they were trying to hack a lot of banks, and they also did. Oh, sorry. They also did hack the Bangladeshi bank. And you might have heard about the Bangladeshi bank heist, which happened in 2016. And it was a way for them trying to steal a lot of money. They managed to steal like less than $100 million, but their aim was to steal like $1 billion. So you can read about Bangladeshi bank heist. You can read about, there's a podcast called Darknet Diaries, and Jack, who's like the host of the podcast, he's actually speaking about this stuff. It's a crazy story how the hackers managed to do it. And Lazarus with the subgroup Blue Norov are the ones who are focusing the financial sector and trying to steal a lot of money from it. So these are kind of like the most interesting, from my point of view, APT attacks. Of course, there are a lot of happening, like Honorable mentioned ASUS attacks and things like that. Like ASUS, the Shadow Hammer called, or of course Olympic Destroyer, which happened in 2018, and it was like super crazy during the Olympic Games. But all of these attacks, they're using three types of three entries: cyber espionage, cyber sabotage, and mass opinion manipulation. About mass opinion manipulation, I have a different presentation, and you can check it out. I presented it at SAS, also at DevCamp security conference in Romania. Check out my presentation. It's on YouTube. I guess it's pretty interesting. It's about disinformation and fake news and everything. But today we're going to focus on the other two parts, like the cyber espionage and cyber sabotage, and both of them are using malware. And now I would like to go to the second part of my presentation where I will be talking about how can you learn to identify malware or to identify cluster of families of malware. Maybe you're a researcher and you want to do research and you want to identify new samples. Maybe you're an exploit developer. I don't know. You might want to see if you get accepted, or if you get like your malware is found, or like you don't know what's happening. Basically the idea is that you can do like a lot of crazy stuff with Yara. And what I want to do is I want to start the story. And the story is like, what is Yara? And Yara was built by a really good friend of us. I met him at one of our SAS conference. His name is Manuel Alvarez. And basically, he created Yara. He now works for VirusTotal. And Yara is a tool for pattern matching. But it's not like pattern matching in the traditional way. It's a language of itself. It looks like C. I will talk about it a little bit later. But it basically allows you to do expression and to have a logic of identifying malware. And this is pretty cool because, first of all, it allows us to share. It allows us to share some results. It allows us to basically, I write a rule to catch some malware families, and I can share it to you, and you can run it on your systems to see if you have that malware on it. Or it allows us to define a set of families, and others can improve on it. So that's pretty cool. So let's see how a Yara rule looks like. I'm sorry, I have like this really bad allergy, and like my nose is like scratching and my eyes are scratching. And so a Yara rule looks like this, and it's pretty simple. It has a meta section, and in the meta section you can add any meta information that you want to use, and it won't be used at all by the engine, the running engine. It then has a strings section, and you can define some variables. You can say A is kind, funny, and imaginary. Like A is kind, B is funny, C is imaginary. And then a rule always has a condition, always. So you need to have a condition. And for example, in our case, we have variable A and variable B and not variable C. So in other words, we want to find friends that are real. So this is just a meta description of our rule, but basically I want to say kind, funny, and not imaginary. So those are real friends. So this Yara engine, of course, I won't go into in depth about this one, but basically the Yara engine allows you to have a lot of constructors and a lot of range. But how does it work? So you have Yara and you have modules. Yeah. So basically you have like a set of files, which are your initial start. You start from some files. You start like with 1 file, 2 files, 3 files, whatever. And then you have a rule. Like, what do you want to catch? What do you want to match over those files? You input those files and the rules into Yara, and Yara provides a list of detected files. And that's it. It's pretty simple. Then how do you run Yara? Well, it's simple. You say Yara binary minus S or not, it depends if you want. You specify the rules file, which is this one, and then you specify the destination file, like which files you want to set, or a destination folder, because you can search multiple files in a folder. So this is basically the destination directory, and then you can use -R to go recursively. So what can we do with Yara? You can identify malware, you can classify malware. You can find new samples based on the old ones. So basically we find the sample somewhere, we find the detection, we find the sample, and then we try to see if we find other samples. Find new exploits, new 0 days based on old ones or based on old habits, old tricks. I will talk a little bit about this one a little bit later. You can speed up incident response by sharing Yara rules and then trying to identify infected hosts. You can increase your defense, and of course you can build your own private antivirus. So that's pretty cool, you know. Like you can have your own small antivirus if you don't trust big vendors. It's totally fine. You can build your own signal signatures. You load them up in Yara, and you scan your system every day with those signatures. And I will tell you where you can find public Yara rules, updated Yara rules, and what you can do with them. So who uses Yara? Well, we do in Kaspersky. We do it a lot, and every serious security company does it. Appliance vendors like FireEye or like Ixia, they're using Yara in order to scan inside their appliances. I think also Fortinet is doing it. VirusTotal is a platform where you can, so let's not forget that the founder of Yara works for VirusTotal right now. VirusTotal is a platform where you can hunt for files in their huge collection with Yara. A lot of 500 companies are also using Yara, and soft spyware developers like Hacking Team. And we've seen them mostly because they were using a lot of Yara. They had like some signatures, and of course, you know, you want to see if you're writing malware. You want to see if your malware is being detected by some researcher. So that's pretty cool. Now, some words about designing elegant rules. You know, okay, you know what Yara is. You know how to use Yara. How do you design some elegant rules? So Yara, it's a programming language. Actually looks like C. So because it looks like C, it has comments. You can add comments, and you should indent your code. So a comment looks like this, like in C, C++, // or /*. And of course, you could use and you could add some contact information to your rule in the meta section, because you can share your rules. So add your name, email, company if you want. It's totally optional. So this is how it looks like. This is how a Yara rule looks like, which is a good rule. So it has a meta section, like Kostin Raju is the one who created it. It has a description, when it was created, the version, the hash where it started from. It has some strings. and it has a condition. Now the strings can be ASCII or wide. So basically you can have like 1 byte or 2 bytes per character, and this allows you to define how you want to search in those binaries on the disk. And of course it has some conditions in order to match. So basically you can say that this is an executable OX5A4D MZ, and file system is less than, this is 5 megabytes, and 2 of these conditions. We'll see later why we have to use 2 of these conditions. Naming your Yara rule, we recommend doing like the following structure. First of all, you define whether it's an APT, exploit, primer, clean, etc., etc. Then the language designator for APT, if it's like an English-speaking APT, like Russian-speaking APT, Korean-speaking APT, etc., etc., Romanian-speaking APT. The actor name, if you know it, like we could say like Turla, and then the family malware name. For example, Turla satellite Turla. That would be an example. So what you can do in metadata and what we recommend, you can also put the author, date, the version, reference, and everything. Also, it's useful if you add like a copyright, depends if you're working like in a big company or not, or if you want to share only with your company. Last modified Yara versions, I didn't see it a lot. In those rules. But the hash is more important because you need, if you write a Yara rule and then it will hit on a file like 2 years later, you need to know where it started from, and you will forget. So basically adding the hash, it will help you identify where you started for, and if you have a hit, you will be able to quickly trace it back from where you started. So I'm checking the chat. I see that there's like some announcement. I think unfortunately I don't know how to read Russian, so I think I will carry on. Okay, so if you want to learn more about best practices, I totally recommend going on GitHub of a Canadian Center for Cybersecurity, like CCCS, and they have like some really good specifications, Yara specifications to do that. So that's pretty cool about this one. So designing detection efficient rules. What can we do about it? Well, first of all, you need to test your rule. You need to test it and to make sure that it doesn't generate many false positives. Using the full word is only recommended when the string is short, else it will slow down the scan. So basically, full word is one of the features of Yara. It's also very important not to try to make Yara rules on the popular import-export. So basically, you have like some popular function calls from Win32DLL, yeah? So you shouldn't make a Yara rule just because you see them in the malware file. You shouldn't make Yara rules based on those ones, because you will hit other legitimate files which are actually using this import table as well to function properly. Remember to use the file size, which is like pretty important. Check the header is very important because you don't want to scan like image files, or you don't want to scan text files if you're looking for some 0-day exploits in a binary, or like with a binary with 0 days exploits. But of course, you should not check the header if you're doing memory scanning. Okay, let's go next. So the question is this a good rule? So maybe if you want to write in the chat, let's say let's wait for 10 more seconds, and then I would like to ask your opinion. Like, do you think it's a good one? Do you think it's a bad one? Does it look like readable? Do you know what you're looking for? So sorry, my allergy is like killing me. It's like crazy. You see like a lot of imports from popular libraries or popular function calls like get proc address, load library A, free library, sleep, get local time. So okay, I will carry on. So basically, unfortunately, this is not a good rule, because it's not. So if you scan it and we have like a set of clean files that we are using, At the first scan, it didn't match any files. So basically, we have a smaller collection of clean files, which is consisted of 30 gigabytes of files, and it didn't match any files. So you might say, oh, this is good. But then when we scan it on a bigger collection of clean files, our collection is called CleanX 2019, we can see that it matched a lot of files, a lot of clean files. So this is not a good rule. So the common mistake is that you should not use like runtime generated strings like this ones before, like for example this one, like sorry, I have an example later. Or you should not put all the possible criteria necessary here, like for example all of A. This is what I wanted to show you. Like all of A is like a too strong condition, very strong condition, and like sometimes it might not work. Another not quite the best rule is what I mentioned, like runtime generated strings. I know that those you can find them when you do like research in your files, but those might not be also good. Also, we see like 19 of them, which is like all of them basically, 19 files, and of course, there is no additional condition like file size or header checks. So this is also like something a bit worrying. Those are code-based strings, which again are not so useful, and it's not a good rule. But let's look at what's better and how we can improve. Well, first of all, we should you can start by using strings to extract ASCII text strings, but you should use also -e to extract Unicode ones. But you have to be very careful. What's interesting and what's pretty powerful is to look at the results manually and to pivot or to identify the interesting one. So, for example, unique mutexes used by the malware, like this one. This is a real case example. Rare user agents, like Nokia 95. Again, this was used by malware in communication with a C2. Typos, software instead of software. So basically, the malware creators, they use a typo. Bam! You can create a Yara rule because it's highly unlikely that legitimate files have this typo in here. PDB paths, also paths that were forgotten by the malware creators, that were not removed, stripped down from the binary. Random IDs, internal module names, or encrypted configuration strings. That's pretty cool. So when you use conditions, it's also good to use 2 or 3 groups of conditions. So that's very important when you do that, because you need to like, it helps you improve your rule. So basically, this is an example of a rule. We have like a first group here, second group here, third group here, and we check for the file size 5A4D like MZ, and we say any of A, 5 of B, 2 of C, and the file size. So basically, this is a good rule which catches Blue Traveler APT samples. So let's talk about elegance and efficiency. So what do you think about this rule? This is another question for you. I'm also checking the chat. I'll give you some time to tell me if you think it's efficient, or if you think it's elegant, if you think it's a good rule, or if you think it's a bad rule. Basically, you can see that they are looking for OSX, PRX, 1A. I don't know what this is. They say X protect rule is true, which again, like, I don't know exactly what it is. They're looking for macro files, okay, and file size is less than okay, and then they're using for some SHA. So do you think it's good, bad? So for the ones who said that it's a bad rule, I agree with you. Basically, this rule will only match 3 files, and that's it, only those 3 files. So the question is, why did you put like this only? If you're looking for those 3 files, it's not a very efficient way with Yara to check that. You can have other tools that can use scan your file system for matching files. What about Isro, which was published from the Department of Defense in August? It was related to Drover malware. Do you think it's a good rule? Do you think it's a bad rule? Do you think they could have improved? We have a description, but unfortunately, we don't have like any other stuff. We don't know where it came from. Well, I tell you, the link is here. You can read the PDF. We can see that there's like there are some files, and Nikita says it's a bad rule. A lot of popular strings. Well, bingo, exactly. So they are doing a lot of popular paths, or like strings, which can exist in other good files, but also they're using all of them. So basically they're saying like, we want to match on these ones and all of this crazy stuff. So it's not quite elegant. If we look at another rule, which again was developed by those guys from the Department of Defense, we see that they have improved a bit here. So basically they say like, we have a file size, we have a header, like this is Linux, this is ELF, and they have like some number of times this string appears. That's pretty good, all fine, but can we have also here, like, what do you think, like good, bad? I would just continue saying that this is unfortunately a bad rule, mostly because if we scan it here and we scan it in with our collection, with our scanners, this rule matches 3 samples which are actually legitimate files. So if we're looking at those samples, we see that we have like this file here, which was part of the bigger string. We have like disaster cache version JSON path. They're looking for JSON, so basically we have this one. And you know, they didn't check properly. They didn't properly check the rule, and it's matching on false positives. So I think it's not a good rule. Now, Florian's rule is Florian's Roth rule is a better rule, mostly because he always writes like pretty good rules, and I suggest you checking his GitHub account, and he has like some really strong stuff. So you can see that he's checking for the header, checking for the file size. In this case, he's doing all of them, but he has these specific imports, specific DLLs, which are basically, he's saying it detects APT17 malware. So this is good. This is a good rule, because he made sure that in order to, he reverse engineered the APT17 malware, and he found out that it's importing these files, and it has these files in the path. So let's check the chat. Okay, we don't have any other messages right now, but I see some people typing. We'll continue because we don't have so much time. We'll continue with our third part, and basically, how can you test for false positives? Well, if you want to start writing Yara rules, it's important that you actually test them, like everything you do, like in software development, testing is very important. Consider writing Yara rules as software development. And the way you can build your clean set is pretty simple. Go and grab a Windows XP installation disk. Grab Windows 7, Windows 8 64 bits, Windows 10 32 64 bits. Those installation files, media files exist on the internet, like clean ones. Grab a Linux installation file, an OS X, some iOS dumps, Android dumps, whatever. Get some public samples from these tools, add them to a folder, to your repository, and voila, you created your own clean set of files. And then over this clean directory, you can test your Yara rules to make sure that they don't generate false positives. Alternatively, you can use also a tool that we have released in Kaspersky. And I have a question from required, but I would like to kindly ask somebody if somebody can translate it, please. And I will get back to you. When I have the translation. So basically, we have released a software that can help you deploy your Yara rules. The system is called Clara, and basically it's an in the cloud Yara-based scanner. So this scanner, what allows you to do is it allows you to test for false positives, to fine-tune your detection and hunt for interesting samples. How does it work? It's simple. Basically, it automates running Yara over a larger collection of files, and allows you to have a web interface where you can copy paste, click run, and then you get the results back. So the software is open source. We have open sourced it in our GitHub account, and on all the web interface looks like this. And basically, you submit your own rule, and then you have those rules, and then it says like this is the rule name here, and then how many files were matched by the Yara and the Clara engine. And basically, it allows you to quickly deploy Yara in infrastructure in a distributed way, so you can hunt for more files. And this is the end of my presentation. I see there are 2 questions now, which are in Russian, and unfortunately I can't read. But before we finish, and I think we have 3 more minutes, I'd like to do 3 quiz questions. So let's go really fast. Based on what I said, what do you think? Is the meta section important to create a good Yara rule? So number 1, it's useful to understand why you've created a rule. Or number 2, it will slow down the scanning. So if you want, you can type in 1 or 2, or 1 and 2 in the chat here, and let's see how many people are voting for 1, 2, 1 and 2, 1 to 3. So Nikita says 1, Nikita says 1, 1, 1, 1. Good. So yes, you are right. The meta section will not slow down the scanning, and it is useful to understand why you've been you created it. Oh, I see more people: Ray, Pavel, Priyan. Okay, good. I have harder question for you. If your rule has too many false positives, what can help narrow them down? Check file size, check header, use the Yara compiler, or put more comments in the rule. So what do you think about this one? Again, you can also mix and match, so it's not exhaustive. So Nikita says 1 and 2. Nikita 1 and 2. Okay, 1 and 2. So nobody wants to vote for number 4? Come on, we love comments. I mean, comments are good, you know. It helps us understand code. But you're right, guys. So 1 and 2 is the right answer. I saw Asterit is saying only number 2, but actually it's also important to check the file size, because you might have, for example, an ISO image. An ISO image containing a Linux installation file has a lot of binaries, and an ISO image is like 700 megabytes. So by checking the file size, you can narrow down this search. And lastly, the third question: can you detect files based only on metadata? Yes, no, or yes if you use the force? So yes, Nikita says if you use the force, anything is possible. Yeah, totally fine. I agree with you. Yeah. Let's see. Meanwhile, if can somebody translate the two questions before, that would be cool. Else, unfortunately, I can't.
Hey,
I'm not able to.
Dan, can you hear me? Dan, can you hear me?
Yeah, I can hear you. Yeah.
Unfortunately, these comments were not related to your presentation. I'm sorry. It's just some questions for organizing game, so we can just skip them.
Okay, so let me finish and then let's get back to the question. So basically, the answer is no. And Asterite had like good spotted really good because the metadata stuff, well, depends. Sometimes you can and sometimes you can't. So it's like you can detect all files only on the metadata for sure, but it's tricky. It's tricky and it generates a lot of false positives. Okay, so the last question. I was tricking you. The last question. Do you think you can catch suspicious malware files without the initial files? So no or yes, using the force of Yara. And this is the very important. This is very important stuff, and I think this is the main information I want you to get with my from my talk. So I see a lot of people are typing, and Alex and Nikita are saying yes, using the force of Yara, and indeed is correct. So basically, you can catch malware files without having the initial sample. So that's pretty cool. So if you want to learn more, here is the link. I'm not promoting anything. Like you can find more information here. And this is the end of my presentation. Thanks a lot, and let's try to answer some questions. And I see a question here from Nikita. Testing about false positives. Are we creating a clean system and checking? Are we creating a clean systems and checking each file on the system using Yara? Yes. So basically, what I was suggesting is that you create a folder with clean files, and then you check your Yara rules on those clean files. If you have any detection on those clean files, and if you're trying to search for malware, then your rule is generating false positives and you need to fine tune your rule. And I think there are no other questions in English. Okay, so I think, yep.
Thank you so much. It was really interesting report.
So thanks a lot. Thanks a lot for inviting me. I would like to thank the organizers for giving me this chance. It's my first time presenting here, and good luck with the rest of the conference.